Welcome everyone, and welcome to this series of lectures on science and claims and understanding claims under scientific scrutiny and how to address claims with a scientific mind. My name is Musa Zahrani. I hold a master's degree in health science from University of British Columbia, and we're gonna learn during these lectures how to address claims in a scientific way, and also to learn how to acquire knowledge and science. And before we start, I would like to thank and acknowledge Professor Jane Buxton from University of British Columbia for giving me the permission to use some of her slides during this lecture. So who should watch these lectures? Well, anyone who has an interest in science, an interest in how to address claims in general, whether it be a medical or non-medical personnel. So by the end of this course, people who attend the course should be able to examine evidence and its strengths and weaknesses. We should be able to know the limitations of modern science, to evaluate claims, especially those made by media and lay persons, and to describe how knowledge is acquired. So why this lecture now? Well, because I'm sure many of us have already heard multiple claims every day during the COVID-19 pandemic, where multiple claims are being heard every day, and people are making claims about finding new treatments, what have you. So how do we know which one of these is true? How do we acquire the proper knowledge, and how do we know which information is accurate, and how can we find the truth? At the same time, there are many people who are questioning or started to question evidence-based medicine as we know it, based on conflicting data from different studies showing some positive finding in one study and negative finding in other studies. And before we go deep into the topic, we'd like to remind ourselves of some of the important rules that we know, the common ground rules of science. It is okay to disagree with people with different ideas or different claims. However, usually we would like people to demonstrate their understanding of the opponent arguments, and to examine why you reject them, and articulate that in an intellectually rigorous and scholarly manner way. Try to use some logic arguments, use logical as well as empirical data to support your arguments. And of course, first and foremost, we need to be respectful to others. So what is science? Well, science is a word, a Latin word that comes from the word scientia, meaning knowledge. And there are many different definitions for science. However, I choose one of these definitions that I thought is a simple one, and I highlighted some of the keywords in this definition. So it is a systematic exercise that builds and organizes knowledge in the form of testable explanations and predictions about the universe. So it is a systematic way. So it is not based on random data. It is a systematic way of collecting data through experiments and organizing the knowledge that is acquired from these experiments in a testable way to have a conclusion or results out of these experiments that you can use to predict some other information about other experiments or populations. So there are different ways to acquire knowledge. The two ways that I want to focus on before we go deep into the topics is deduction versus induction. So deduction reasoning is an old concept, so it is not new. Many people consider Aristotle as being the father of deduction, who lived more than 320 years BC. And deduction is a logical reasoning. It is based on a process of reasoning from different premises, we call them. One or two statements that we call premises, and to reach to a logically certain conclusion. So here is an example of deduction. So the premise or statement number one, if you say dogs get fleas, and premise or statement number two, Tilly has fleas, then the conclusion is Tilly is a dog. Well, these premises, although the premises are true, the argument is not valid. Thus, the conclusion is actually does not follow nicely from the premises. So the conclusion is wrong. However, if you say that all dogs have fur and Lucas is his dog and Lucas has fur, then the premises are sound and true, and thus the conclusion, which is Lucas has a fur, Lucas has fur, is actually valid and true. Whereas in the other hand, induction is a method of reasoning in which the premises are viewed as supplying some evidence for the truth of the conclusion. And again, I highlighted and read some of the key words in this definition. So basically, the premises are used to supply some kind of evidence for the truth. So it is not following with necessity as deduction. However, induction gives you only some evidence with probability. So the conclusion of a deductive argument is certain. However, the conclusion of an induction argument is probable. And that is why, based on the modern science, we use probability. So we're nowadays during the modern science and in medicine, we use probability such as p-value and confidence interval, because we never certain about anything. We use possibilities. So confidence interval, 95% confidence interval, for example, or p-value of less than 0.01 or 0.05, etc. So here, induction based on probability. So you can see now that, or recognize now that one major difference between deduction and induction is that unlike deduction, induction reasoning allows for the possibility of falsifiability. So having a possibility that the conclusion could be false. And this is very important. So which we will discuss in details later on. So falsifiability, so the ability to falsify the data. So instead of having valid or invalid conclusion in deduction, we should not use these words in induction. We should rather use the words strong evidence or weak evidence, because we are never certain about any conclusion if we use the modern induction. So here we describe how probable the conclusion is. So most likely the result is this, but we cannot be certain. So if the premises or the statements are true in induction, we think the conclusion will less likely to be false. So it is improbable that the conclusion will be false if the premises are true. Whereas in deduction, if the premises are true and they follows nicely with the conclusion follows nicely with the premises, then the conclusion is necessarily true. So, as we just said, the conclusion follows probably from the premises and inferences. So here's an example of deduction on this box on the right side. So deduction, so if you say all men are going to die, so that's premise number one. Premise number two, Socrates is a man. So the conclusion, Socrates will die. So this is deduction. If you get another example of induction on the left side, if you say Socrates was Greek, so this is premise number one. Premise number two, most Greeks eat fish. So the conclusion, Socrates probably liked to eat fish or ate fish or eats fish. So here, we do not have a certain conclusion, but we have a high probability given that Socrates is a Greek and Greek like to eat fish. So most likely Socrates likes fish. You can see now the difference between induction and deduction hopefully becoming more clear. When we use deduction, starting with logic, reasoning, you're starting with a theory. So confirming a conclusion or a theory. And based on that theory, you can then build some hypotheses and apply some observations, etc. Whereas the other way around, induction is viewed as collecting observations outside your reality. So doing the experiment outside of your mind, collecting the data of the experiment of that experiment, and then based on the data that you collect, then you get the conclusion. After which you get a theory based on the experiment you built. So it is the other way around. Ultimately, if you think about arguments now as deductive or inductive, you will end up having this kind of chart. So deductive arguments will be either valid or invalid. The conclusion will be either sound or unsound. Whereas in induction, as we just said, we're not talking about valid or invalid. Rather, we're talking about the strength of probability. So being either strong or weak, the evidence will be either strong or weak. So moving on to the scientific method. So the scientific method is believed to be an empirical method of acquiring knowledge. Empiricism or empirical evidence comes from observations, from skepticism about the observed information, formulating hypotheses, collecting the data, analyzing them, and then coming up with a conclusion. So this is what the current scientific method is. So it is based on data, observation, experiments, and reaching to a probable conclusion. There are so many different definitions that you can find on scientific method, and they all rely on the same concepts that we just mentioned. So it involves formulating hypotheses via induction that we just mentioned. Based on such observations, experimental and measurement-based testing of deductions drawn from the hypotheses, and refinement of the hypotheses based on the experimental findings. So one important feature of the scientific hypothesis or scientific method, as we mentioned earlier, is the ability of falsifying the data. So the modern science or modern scientific hypotheses must be falsified. So this implies that it is possible to identify a possible outcome of an experiment or observation that conflicts with the predictions. Otherwise, the hypothesis cannot be meaningfully tested. So you cannot do an experiment being sure that the result will be valid. Otherwise, that's a sort of deduction rather than induction. Whereas the modern science based on induction or empirical evidence, you are starting your hypothesis or your experiment with having put in mind that the conclusion could be wrong. An example of this, if your hypothesis is that all penguins are black. So let's say that you said all penguins are black. So how many penguins you need to observe in your population to reach this conclusion? 100 is enough, or 1,000 is enough, or 100,000 is enough? It's really hard to know. So if you let's say that you did a study where you looked at 100,000 penguins and they were all black. How certain you are that all penguins in the world are black? You cannot be 100% certain. And that's what the modern science tells us. However, you can disprove your hypothesis if you find one white penguin. So then it is falsifiable. You can falsify your hypothesis if you find one opposite prediction. So as you can see, there are different important elements in the scientific method. So starting with questions, hypotheses, theories, construct these hypotheses, collect the variables and the data from a study, from making experiments, and then you can formulate the results empirically. So some people think that Aristotle started empirical evidence. However, it is not really as the scientific method nowadays are explained. So it may be started back then by a simple thoughts about going beyond the deduction and trying to have some observation. However, it was until Ibn al-Haytham, which is considered by some people to be the father of modern science, where basically he started to emphasize on experiments and experimental data and focusing on reproducibility of these results. However, as you can see here, Ibn al-Haytham, in the statements, he relies on falsifiability. So he emphasizes that you need to have a skeptical mind and try to think of any possible way to falsify the data. However, most people would consider Francis Bacon to be the father of empirical evidence and the modern science, who is a British scientist who lived between 1561 and 1626. So he came, of course, after Ibn Haytham. So this is how, personally, I would think about modern science nowadays. So the modern science, we can divide it into three major branches. So the natural branches, natural sciences, such as biology, chemistry, physics, etc. You can also divide this into basic science and applied science, and medicine comes in the applied science branch. The second branch is social sciences, such as psychology, social sciences, etc., which study individuals and societies. And the third branch of science is the formal science, which relies on logic, such as philosophy, mathematics, etc. One big difference between the first two types, the natural sciences and the social sciences, and the third type, the formal sciences, is that the formal sciences depends mainly on rules, logic, and deduction arguments, whereas the first two branches, natural sciences and social sciences, they rely heavily on empirical evidence, on induction. And actually, it is thought that the modern explosion in science in the last few decades, and it's believed to be related to understanding and applying induction and empirical evidence, because for so many years human beings relied on deduction. However, there was no big advancements happened in science until we started to move to modern science and induction. So when human beings moved to induction and empirical evidence, we started to see this very nice explosion in all the different branches in medicine, in science. Medicine is just one of them. So why people now, especially scientists and people who basically believe in science, make themselves very adherent, I would say, to science, and they don't believe in anything other than the scientific way? Well, because many scientists believe that the scientific method is the best way that we have derived to determine what is real and what is not real. So it is the best way to reach to the truth, based on this very big recent achievements in the science. So it is a way of asking testable questions, collecting evidence, and evaluating that evidence. So here are some of the other characteristics of science. Science is a process of inquiring about the world. It is a system which is at pains to reduce bias. It attempts to be as objective as possible. Science is open to external scrutiny and review, and it is based on precise descriptions, predictions, and why it is precise? Because we want other experiments to replicate the results of these data. And also, it relies on testing hypotheses with experiments. So here are some other characteristics. Science helps to form models, which allow some predictions for the future. But there is no one single perfect model. Science usually will tell us there are different models. Some are better than others. And the ones that we think are the best, will allow us to progress further in science. So the new knowledge leads to refinements of the existing models or creation of new models. And science helps us to establish some tools to guide us to make decisions, rational decisions, whether it will be on different treatment in medicine, for example, or other decisions in other branches of science outside medicine. So how scientific progress happens? Can we prove something? As we said in the previous examples of the penguins, we cannot actually prove something with certainty. We can disprove it, but we cannot prove any hypothesis. So once we have quote unquote proven evidence, although this is a misnomer, then we can progress with having new ideas on top of the existing ones. And the refuted concepts usually are set aside, and then we try to build some new models based on the proven old models. So this was the first part of this series. I hope it was useful. I am very open and happy for any discussions or questions or any corrections of any of my slides or thoughts. We will be moving to the next part, which will be part number 2 after this break. So thank you very much again.